lesson, we're actually going to start in doing estimating digits in a quotient. In other words, how do I divide by estimating? I'm going to be upfront with you guys. I'm not a huge fan of estimating. The first few years I taught math, I basically skipped these lessons. I hate them so much. Why? Because for math, one thing I love about math, you do the work, you don't make errors, there is one right answer. In estimating, there's actually a ton of different answers that could be correct. Because a good estimate is only going to get you within about 20%. I mean, a really good estimate gets you like on the number, but the whole idea of estimating is just to get close. And as a mathematician, that's not something I like. Here's where I changed my mind. When I was in Germany, which is where I started teaching, one of my fellow math teachers, who I talk to much like I do Miss McShan, where we talk every day about how to teach and what we teach. I told her that I didn't like estimating. She's like, you know what? I'll be honest, I didn't either. Till one day I was at the BX, and two of our fellow teachers were at the BX with us, and one of them picked up some clothing that was 30% off. And the other teacher was like, wow, that's a pretty good deal. How much is it going to cost? And the first teacher looked at her and said, I don't know. I'll see when I get to the register. That's kind of like, what? Hello. So the reason we're teaching this, guys, this is a life skill. Quick question. When AFES put stuff on sale, do they always get the correct price put into their database? No. They don't. I've caught them at it before. So if I don't know what I'm supposed to pay when I get to the register, if they don't have the right price in there, am I actually going to know that? No. No. So this is a life skill that can save you money. The whole idea on this is you make the numbers easy so that you can actually do them mathematically. It's just to get close to what the answer actually is. So we're going to kind of breeze through this one relatively quickly. You can ignore that drop on the mic. It was almost a catch. But here's the idea on this. I'm sorry? And hand grenades and nuclear bombs. And hand grenades and nuclear bombs. You got to be a military person. We're military teachers now. We're on page 50 in module 2. It should say 6-2 on top, and then page 50 on the bottom. So our first one, just to show you the mental math that we're searching for. If I divide 150 by 30, should be easy, right? 3 goes into 15 5 times. So even though those are like multi-digit numbers, it's still actually really easy math, right? It's just 5 times. Yeah. This is the idea behind estimating. Get the numbers to where they're really easy. Now, let's go to this next one, and we'll start talking about it. Now, they want us to do one-digit arithmetic facts. I'm not going to focus so much on that one, except for the divisor. We do want our divisor to be one digit, because that's what's going to make it easier for us. And that's also where I want you to start, because the whole key on making this math easy is understanding what the number is and how it's going to work with the other number. So if it's a number like 11, that one should be really easy to round, right, to get an estimation. What would I round it to? 10. Does that only make sense, right? Now, because it's 10, 10 works well with anything, right? So my other number, I'm just going to round to something nice and even to make that math easy. So 2,970, I would go to 3,000. Does that make sense to everybody? Yeah. And that's really kind of the whole concept today, guys. Do something that makes sense for you. So that means it's going to go 3 times, or my answer should be somewhere around 300. So if I get an answer that's 3,000 something, I know that I'm wrong, right? Which is kind of what the estimating is for. Now, one thing I don't like with Engage New York, they want you using calculators, and Mrs. McShan and I do not. There are a lot of you that still need a lot of work in developing your number sets. So for these, I will use a calculator for you, just to give you the idea what the right answer was, so you can see how close our estimates are. First off, do you think close to 300, or will you be really far off? You think we'll be like within 30, within 50, 100? How close do you think we'll be? What do you think? You know the answer? 270. Okay? Yes. I divided 2,970 by 11. And then my calculator told me it was 270. Had I done like serial, it actually wouldn't have been too hard. It's going to go in twice there. That's going to give me 777. It's going to go 7 times, so there's nothing left. So technically, you could do it mentally on this one because it's relatively small numbers. But again, we're just trying to introduce this concept of rounding to you.
Plus, I can basically divide 11 and 209.
Yeah, 11 is not bad.
Yeah, because
Now, here's why and we'll talk about this in a second. So a 12 is going to round to what?
11.
Why are you writing in 10? Should he not write in 10?
No, he absolutely should not be writing in pen. Gabriel, you know that. Not good, Gabe. So my 12 is going to round to what? 10. So that gives me a lot of flexibility on the other one. I'll give you another hint. If I am rounding, your best option is if I round down on one to round up on the other and vice versa. Okay? So I went from 12 down to 10. So 4,700, where do you think I should go? Up to 5. Let's do the opposite. It's going to give us a better estimate. So if I go up to 5,000, divide that by 10, that's going to go about 500. Okay? So using the calculator, 4,752 divided by 12, 396. Were we close? Relatively.
You keep using calculator.
Do what? Yeah, it says right here.
Oh, we don't have a calculator. So
That's why I'm doing it for you.
yeah, because we're
Guys,
not on here.
does anybody else see something else on these numbers that might work? Yes. We'll talk about it at the end of class.
Yeah. I don't want to break down.
Guys, anybody else see something on these numbers? Sadie, do you see anything on these numbers? 12, 4,700. Nobody? Sean? Do what? I divided 4,752 by 12.
Oh, she sees, I think,
Yes?
4,700 is close to 4,800. So it should be about 300 for it.
300.
It's 3,600.
But we said 4,800, right? 47 is close to 48. So if you have good number sense, guys, and you see that 47 is really close to 48, 48 actually works well with 12, doesn't it?
Yes, it's like. Oh yeah.
Wow, look how close that estimate was.
400.
Why is that one so much closer than our first estimate? What do you think, Wesley? Because we didn't change the 12 at all, right? So our divisor, we didn't switch it at all. How much did we change our other number? We only changed it by 48. That's not much at all, is it?
Yeah, for 12, we changed.
Okay? So if you have the number sense that you see that 12 and 48, you can get a more accurate estimate. But that's not what we expect out of all of you. We at least want you to be able to do the single digits, okay?
Because if you know your multiplication, so it should be easy.
Should be. But unfortunately, there's a lot of you that don't know your multiplication charts, which we'll talk about in a second.
Are you talking about me?
No, actually, and here's one of the problems. I don't really see your guys' work that much other than the chances I get to walk around. So Miss McShann has a better idea, and she has vouched for you, Sean, so I believe her. She's actually a really good mathematician, so. Okay, our 19 is going to become a 20. So if I'm working with a 2, what do I want that 116 to become? 12, right? So that's going to work well best with 12,000 divided by 20. So that's going to go 600.
600?
Yep.
Oh, I see.
So it's going to be somewhere in the round of 600. What was that, Kaylee?
She's not a fan.
This actually should make it easier for you. Let's check our actual math. 11,006. Oh, let's try that again. 11,647 divided by 19. Miss McShann got close to me. I got nervous.
What? Why are you blaming everything on Miss McShane, Mr. Moore?
Because she was there. Did you not see her?
She was walking by.
Okay, on this one, was our estimate close to our actual answer? It's actually really close, right?
Just at 13.
It's one of the better ones we've had. Why is that one so close when the other ones have not been quite as close? What do you think, Madsen? Aaron? I didn't change the numbers much, right? 19, I only went up 1 to 20. 11,006, I only went up 353. So really, I didn't switch it that much. So that made it stay close. Sean?
So you look at the next digit to the right, and if it's 5 or up, 5 or above, it rounds up. So if it's 5 and below, it goes down.
And we'll get to that one in just a second. Okay, 18. That one's going to become what? 20. Jonah, please stop talking when I'm talking. Our 40,600, what do you want that to become?
40,000.
Which one, 40 or 41?
41.
40 is going to be easier for us to do mentally, though, right? So we'll make that one 40,000. The other big on that one, guys, for me, is going to be the fact I went up on this one. So I'm actually better if I can go down on that one. Again, if I can do opposites, it's going to keep my estimate closer. So that one's going to go about 2,000 times.
Yes.
So here's our calculator. 40,644 divided by 18 gives us 2,258. Is that a good estimate?
Yes.
It's not bad. We're within just a little over 10%. So that was actually a pretty good estimate on that one.
Yes.
Okay, now let's look at this next one. This should be fun.
Oh, this one.
Okay, 15. So here's where what Sean was talking about comes into play. Our rounding rules. 15 is going to go to what? Why? 5 and up. 5 and up, I round up. So 5 and up, that's going to go to 20. So if that's a 20, what do I want that 49 to be?
48. It's 20. Oh, no. No, it stays the same because if it's 5 and below, it stays the same.
Okay? In this one, I would probably go to 50. I wouldn't have a problem with going to 48 because 48 actually works, well, they both work well with that. But so if I do 50,000 divided by 20, that's going to go to about 2,500. Now, here's one where, again, if you have really good number sense, you may want to do something a little different. Anybody see something about the 15 and the 49?
Yes.
Sean, what do you see?
We didn't really change so much.
We changed the 15 a lot. We went from 15 to 20.
Wait,
Yes?
49 is about 45. 15 times 3 is 45.
49 is about 45. So if I did this as 45,000, I could leave that 15 like it is, right? So then it would be somewhere around 3,000. So which one do you think is going to be closer to our answer, 2,500 or 3,000?
3,000.
How many think 2,500? Raise your hand.
You know what? I don't know.
I think both.
Sean, with our good number sense, just said 25. You guys sure you don't want to join him? Okay, hands down, 3,000. Raise your hand. Ooh, Oh, wow. Okay, half the people on my side didn't vote. That really wasn't an option.
I vote both.
At least your side did well at voting, Mr. Chan. Well done. Okay, let's try it. 49170 divided by 15 gives us. So yeah, that was a way better. Now, here's the irony. Look at this, guys. How much did I change it from 49,170 to 50,000? I mean, that was basically 830, right?
Yeah.
How much did I change it going from 49,000 to 45,000? 4,000? Yeah. I dropped it 4,000 to get it to 45. But here's the big deal. How much did I change my divisor? None. So I used the exact divisor. So even though I did a much larger rounding as far as the number I was dividing, because I didn't change my divisor, it actually came in a lot closer. Because here, I actually did a huge change in my divisor. So that makes a big change in it. So if you've got the number sense to be able to say 15, I can keep that and do 45, versus 20 and 50, you'll get closer. But is this a bad estimate for our answer? No, it's not bad. It's within 20, a little over 20%, but that's still not a bad estimate. Yes, question, Kaylee? Do what? Because when we're rounding, the rule is if it's a 0 to 4, my number stays where it is. If it's a 5 to a 9, I go up 1. Okay? So because that's a 5 in my second digit, that means I need to round it up to 20.
Yeah, which is right.
It's like kind of like that thing in fractions.
Sure, kind of like that thing.
Go back
Oh, I also learned in 5th grade. So.
Okay, this one shouldn't be bad. 27, what am I going to round that to?
30.
30. So the 918, I'm probably going to want to round to 900.
Oh, this is easy.
So it's probably going to be somewhere around 30.
So easy.
So I do 918 divided by 27, and I actually get 34. Is that a good estimate?
Yeah. Oh, 30 was the closest.
Okay.
Oh, wow.
So do you guys see the benefit to estimating?
Yes.
Let me give you a second benefit. On these tests that you guys are going to be doing next week, Thursday and Friday, we are doing mandatory testing. It'll all be on the computers, but even though it's on the computers, parts of it you aren't allowed to use a calculator.
Oh.
So those parts, if I do a quick estimation of my answer, and I say, oh, I should be somewhere around 30, but then I get an answer when I work it out that is 312, do you think I made an error?
Yes.
I need to probably go back and check my work, right? Does it take long to do that estimate?
No.
No. So this is the idea on this, guys, give you a really quick check to make sure that your answer is reasonable.
Actually, I can clarify that's actually 900.
Yep. Okay, so the first part, really easy. 10 problems. Wait, what?
I thought our homework was
Yeah, it was
page 6.
Oh, that's right. Miss McShan got me again on this one.
You fell for a trick again.
I was like, you know, these guys have Monday off. They have almost a whole week to do this homework. I don't think it's a big deal, but Mr. Chan pointed out this estimating is more like a life skill. It's not actually on your testing. So she made a very good point. You probably don't need extra work on this. So you can actually cross out page 54. You don't have to do anything on it.
Thank you.
So turn that, guys. Cross that one out. Go to the next page. No, page 55. Do what?
Guys, lesson 13 in punch.
No,
I thought we were doing this on our own.
not yet. We still got to teach you some more. This is actually the crux of today's lesson. Let me introduce this by saying the very first time I looked at Engage New York 5 years ago when we got this program, this was one of those lessons that literally drove me crazy because I was like, holy cow, look at this homework. I have 6th graders, and I'm going to make them, listen up, quiet please, let me talk. I said, I've got 6th graders, and I'm going to make them take 1,775,296 and make them divide that by 32 without using a calculator. Guys, quiet. Quiet down. I'll be honest. I was like, I would struggle to do that. I don't know that I can make my 6th graders do it. And then I taught this lesson because being new to the whole module system, this entire system, I taught every single page of every lesson. And after I taught it, I was like, you know what? This is actually really cool. This is, if you'll do this, this isn't actually hard. So let me show you what I learned. First off, we're still going to do our estimate, just make sure our answers are reasonable. If I have 19, what am I going to round that to? 20. So with a 20, what do I want that 70 to be? 70. So I make this 70,000. Dividing it by 20, that's going to go 3 times 5 and then 2 zeros. So it's going to be somewhere around 3,500. So I now already have an idea of where my answer is going to be at, right? Here's what caught me by surprise, because we've actually done tables quite a bit already, right? So the tables we've learned are actually really easy to do, aren't they?
Yeah.
Because all I have to do is, and I'm going to have you guys add a column in here, and we're just going to go 1 through 9. And then to make a table, I just take the number and I add it to itself, right? Is 19 plus 19 hard?
And you're playing boy 9.
In a minute.
Yeah.
Is 19 plus 19 hard to do?
No.
I think even Micah could do this one. Oh, you can't? No. Oh. So I was right. Well, that's what I said, Micah. Gosh, I was giving you credit.
I don't think he's like Eric. I don't think he's like
Now, guys, remember, when I'm building a table, it's really easy, right? Because all I'm going to do is add that same amount. So I'm just taking the 19, adding it to the next one. So that becomes 7 and 5. Is anybody seeing a pattern on this?
Yeah.
I can't hear because my guys keep talking.
Does anybody see a pattern?
Oh, yeah.
Cannon? It's like a 9s table. So it's just going down by 1 on the 1s, right? And how much is the 10s going up by?
Oh, I see. So basically,
Because it's a 9, all I'm going to do is go down. 6, 5, 4, 3, 2, 1. That's a 2.
You can only do that.
These are only going up by 2s, so that's going to be 7, 9, 11, 13, 15, 17. Now you can only do this when it's 9s, guys. Other tables, you can look for other types of patterns, but if it's something that ends in a 9, this is a really cool pattern you can do every time. Now, why do you think I'm only doing 1 through 9? Yes? Because if I'm going to be dividing, I'm not going to get bigger than 9, right? Because I'm doing it individual by digit. So here's where I had my aha moment. Watch how easy this becomes, guys. If I have 70,072 and I divide it by 19, I now have a cheat sheet. I'm teaching you how to make a cheat sheet. What kind of cool math teacher is that? So now all I got to do is say, will 19 go into 7? No. Will it go into 70? Yeah. And look, I've got a cheat sheet that tells me it's 57. It's going to go 3 times.
And you're telling us, are you making us cheat, sir?
I'm not making you.
Yeah, you are. Making us cheat.
I'm showing you an easy way to do this. Now it's 130. The closest I can get without going over. Guys, please quiet down. We're still recording. Is 114. So that gives us a 6. Reading this one down, 167. Now it's going to go 8 times. Subtract 152. Gives us 5 and a 1. Our last number comes down. 152 we just did. So our answer is 3,688. Was that close to our estimate?
I don't get it. Oh my God. How do you not get it, guys?
Was that chart difficult to make?
No.
Shouldn't be. Literally all you're doing is adding, guys. Once I had that chart, was this part hard to do?
Wait.
No.
Hang on, Mr. Moore.
There's too much underlying noise.
So this was, for me, really the big aha moment on this. This is actually a really cool tool, guys. The division algorithm, that is what this is officially called, is the division algorithm, guys. It basically involves building a chart for your multiples and then doing the long division to figure out what your answer is. Yes, Cannon? Because I've already got all the multiples, so when I'm doing the division, I've already got the answers to what the next step is going to be.
Mr. Moore.
Yes, Sean?
So, you said plus 19 for those ones. I also figured out something. See how 1 is 19? Just times it by 19. 2 times 19.
Yeah?
All of them by 19.
You do, but normally to do that multiplication, I'd have a whole bunch of work shown over here for every single one, right?
Yeah.
But if I'm just adding 19, I can literally do it mentally right here on the table. Okay? So let's do another one together to kind of show this. They had you do it on this page. I kept it on the same one so you didn't have to flip back and forth. Oh, wait, Mr. Shan, you wanted to do this one.
Why do they do this every time? Okay, guys. All right, let's start with our divisor. What can I easily round 315 to? 300. And if I rounded this one down, I'm most likely going to round this one up. So what can I round 14,175 to? 15,000. Is 15 an easy number for 3 to go into? Yes. Can 300 go into 1? 15? 150? 1,500? How many times? 5. And that's 0, 0, 15. Bring down my 0. Can it go into 0? No. So my answer is 50. So let's see if we get close to 50 in our actual division. Yes, ma'am?
Wait, when you're dividing sister, and then minus 3 zeros and then 2 zeros.
Okay, awesome.
I was just thinking that if you're dividing 300 by 15,000, I thought that if it was 150,
If you have $150,
1,500, I could take away the 2 zeros and just do 3.
kind of. All right, guys. So the first thing we do when we need to divide is our multiples table. How many boxes should it have? Not how many columns, how many boxes? 9, because that is the biggest number you can put at the top of a division problem at one time. I number them. what am I counting by in my multiples table? Why 315? Because that's what? That's my divisor. That's what I'm dividing by. So I am counting by 315 each time. So I'm going to show that on the side. 5 plus 5 is 10. Carry my 1. 1 plus 1 is, plus the 1 I carried is 3. And 3 plus 3 is 6. And then I add 315 again. 0 plus 5 is, 3 plus 1 is, 6 plus 3 is 9. And each time, all I'm doing is adding the same number over and over again. So 5 plus 5 is, carry my 1. 4 plus 1 is, 5 plus 1 is 6. 9 plus 3 is 12. I know more than 3 people in this classroom know the answers to these questions. 0 plus 5 is, 6 plus 1 is, 12 plus 3 is 15. Plus 3, 15 again. 5 plus 5 is 10. Carry my 1. 7 plus 1 is 8. Plus the 1 I carried is 9. 15 plus 3 is 18. Plus 3, 15 again. And sometimes it helps to write it on the outside so you see what you're adding. 0 plus 5 is 9 plus 1 is, carry my 1. 1 plus 8 is, 9 plus 3 is, carry my 1. And 1 plus 1 is 2. Again, I'm adding 315. 5 plus 5 is, carry my 1. 1 plus 0 is, plus 1 is, and 22 plus 3 is, and the last one, 315. 5 plus 0 is, 2 plus 1 is, and 25 plus 3 is. That's what you do each time, guys. Okay? I know he goes through it so fast, sometimes it's hard to understand. You're just adding it over, it's true, over and over again. Okay? Yes?
What if I hate that stinking chart?
You still have to do it.
Thank you. How did you know?
I am very smart.
What happens if I don't do the chart?
Then you get no credit.
No.
Ask the person that got a 0 on their last test because they showed no work. I'm not saying any names. I'm sure you'll find out eventually. 5, 4, 3, 2. All right. So can 315 go into 1?
No.
Guys, I always put a 0, so I'm lining up my numbers. Can it go into 14?
No.
Can it go into 141? No. If you have $141, can I borrow 300? No. Can it go into 1,417? So we look at our chart. How many times can it go without going over 1,417? 4. Guys, pay attention. The number of times is what goes in your answer. And the answer for that is what you are subtracting. 7 minus 0? 1 minus 6? You borrow. 11 minus 6? 3 minus 2? And bring down my 5. How many times can it go into 1,575? So again, the number of times goes in your answer, and the answer is what you're subtracting. So when you get to a 0 remainder, you know you got it correct. There should be no decimals or fractions or remainders on these problems today. So our answer is 45. Is it close to our estimate? Yes. So we know we did well on both problems. Does anybody have any questions about how to do the multiples table? and how to use it to answer an actual division problem. Guys, you are not doing the multiples table for your estimation. You're only doing it for part B when you have the actual division. Got it? All right, you have exercises 1 through 5 starting on the top of the next page. You need to do A and B for all 5 of them. You have until lunch and then a few minutes after. Go for it. You may work together.
Okay, so now we're all working together. The kids are still working silently. So I'm just going to talk through it while they're doing this. So here, again, we always start on the divisor because that's going to help us understand what I want to be looking for. Because I have an 8, that 488 is actually going to work really well for the estimate. So we do 480,000, meaning it's going to go somewhere around 6,000 should be my answer. Building the table really shouldn't take you guys long. I know a big piece of this is going to be your basic facts, which we're going to talk about in just a little bit once I bring it back to everybody. Again, whatever my divisor is, that's where I'm starting. I'm just adding that much every single time. This side I added ones. So that gives us 1,656, 14, 12, 13, 12, 10, 11, 10, 7, 8, 9, 8, 16, 16, 13, 14, 14, 11, 12, and 12, 9, 10. Once we have that, all we need to do is take our actual numbers, 484,692, dividing it by the 78. Excuse me, it's not going to go into 4 or 48. So our 484 gives us a 6. So subtract 468. 16, 166 is going to go twice. So subtract 156, gives us a 10. 109 is going to go just once. Subtract 78 gives us 31. 312 is a 4. So our actual answer, 6,214. Next one. Again, starting on the divisor, it's going to be 30. This one I'm probably going to go with 300,000. Wouldn't have terrible heartbreaks if you went with 270, but we went up here, so it's better to go down. That's why I would say that. But in this case, the 30, we went down here, so it'd be better to go up. So we're better off anyway. Gives us about 10,000. On our table, again, the tables, the more you do them, the easier these are going to get to be. 1, 2, 3, 4, 5, 6, 7, 8, 9. Kaylee did learn earlier that it's actually easier if you use a ruler. Unfortunately, I can't on the board, but no, I said Kaylee learned an important lesson that it actually works better if you'll use a ruler because you get nice, good lines. But unfortunately, on the tables up here, I can't use the ruler because as soon as you touch something down to it, it draws a line. Not that I'm listening to you guys in the background because you're supposed to be working, not talking. 281,886. Don't laugh, Cannon. I'm allowed to have my little moments where it sounds like I'm a crazy person. Hopefully the mask wasn't affecting how well y'all are hearing me at home. For once, you weren't talking about me?
I'm pretty sure she was talking about you.
I think so.
What? Like when your mask is pulled down like this, she'll say, I can't really hear you that well because your mask is down. I don't really get it. You don't fix the mask, I'm not listening.
See, Miss McShann is just mean sometimes. I've been... Guys, you're supposed to be working quietly at your desk. Sorry for the delay at home. They were distracting me in the background. It's the students' fault. Oh, goodness. 138 gives us a 4. Minus 132 gives us a 66. So our actual answer, 8,542, well within reason of the 10,000 estimate. So we're actually looking pretty good on that one. Next two, this one's gonna be close to 40. So 22, I went up on that one. I probably would go down on this one to 2 million. Just because I again like to do up and down if possible. So this one's gonna go by 4. That's gonna make it about 50,000. Doing my table. Guys, be nice. Don't tell each other to shut up. That's Miss McShann's job. She does that to me all the time. I am nothing but nice to Miss McShann. Oh, actually, this is kind of cool because we're seeing a neat pattern here. So every 3, we're going to be having the double numbers. It's a good check to make sure I'm doing my math correctly. Because we can see the 111, 222. The next one will be the 333.
And some of mine are still talking. Let's see.
Wow, thanks to my side, they actually behaved for once.
Don't let them get you on the way to again.
Me? Why do you always blame me?
You were the first one to start it.
You guys are supposed to be working silently. I'm just talking. I'm talking to the people on the recording. So this one's actually working out pretty well. Now, here's a really big one, guys. When I have a number that's smaller than what I'm done, I need to make sure I put a 0 there before I bring that next number down. So 151 is going to give us a 4. Minus 148 gives us a 3. And a 1. So 6,200, no, I'm sorry. 62,041 is actually within range of our 50,000, so we're actually looking pretty good on that one as well. Our last couple here, 112, that's going to be about 100. That's close to 1 million. So we'll do 1 million and 100. Means that one's going to go there. So again, we're going to be somewhere in that 10,000 range. Ooh, she even broke out the doorbell. They're being bad today.
Wow, Mr. Wow, that's not a word. You start us off again. You just more.
I'm literally just talking to the people at home.
You guys are giving you the
Now you even make me make errors on the board. This is really bad.
You're worse than the kids.
You cannot do that.
6, 3, 3, 8, 4, 4, 10. So that's 5, 6. No, they couldn't hear her at home, I'm sure.
It's really hard being the only adult in the room sometimes.
I know. But I still appreciate you. 952,448. Uh-oh, I feel a doorbell coming again. At least it ain't at me. 14 gives us a 5. 564 is going to be the 5, so it's 560. Now it's just 44. I missed a number. Forgot to put the 5 in there. 44 is not going to work, so bring down the 8. And nope, that's a 4, not a 3. So our actual answer, 8,504. Again, that's reasonable considering we thought it was going to be somewhere around 10,000. And our last one, 245. That's an interesting one because we're kind of right in between all of the numbers, but we'll use the strict grounding. We'll go down to 200. So we take that one up all the way to 2 million then. So in this case, here's our 1. So again, we're looking at an answer somewhere around 10,000. So we've got some pretty big ones. 1, 2, 3, 5, 6, 7, 8, 9. And our number is 245. So that's all we're adding each time. That's going to give us 490, 513, 6, 7, 10, 7, 8, 5, 12, 10, 12, 10, 6, 7, 4, 5, 11, 6, 7, 10, 5, 6, 9, 5, 10, 11, 12. So 1,823,535 divided by 245. This is the type of problems I didn't think we would be doing as 6th graders, but again, once we have our table built, these aren't that hard. So 1823 is going to give us a 7. So subtract 1715 gives us an 8. 1,085, we're looking at a 4. Subtract 980. 501. 1053, it's going to be another 4. So subtract 980 once again. 3,735. Just happens to be a 3. We came out nice and even. So as you can see, what looks like a really daunting problem, if you'll take the time to build those multiplication tables, really quite simple. Okay guys, so now I'm going to address the class again. I'm talking to you guys again now. So here is what these look like.
Guys, test and check your answers.
Check your answers, see how far you got. If you weren't able to get all of these, we'll have the video up. I'll be putting it up next period. That's our prep today, so it should be up by the time you get home. So if you need review on any of this stuff tonight, you'll be able to look at it. Please stop talking. Please stop talking and listen. Our first one, you build your table. The estimate came out around 6,000. I used the numbers, I rounded that up to 80. And that one, I went down to 480 because 8 will go into 48 well. So I figured somewhere around 6,000, the actual answer, 6,214. Very reasonable. The second one, this one, I went down to 30. So from 281, I went up to 300,000. If you went down to 270, it's actually closer, but you could do either one. My estimate came in around 10,000. When you do the math, 8,542. Yes, ma'am.
Actually, when I was
Subtracting.
subtracting on number 2,
Hey guys, please stop the sidebar conversations.
when I was subtracting on my calculation after, like, you're like putting it down. Never mind.
Okay, since we only have 3 minutes left, I won't mind. Okay, our next one. I went up to 40. So because I went up there, I decided to go down to 2 million. So it gave me an estimate around 50,000. Actually doing the math, it was 62,041. So again, we're in the same neighborhood. 12,000 may not sound like close, but when you're talking 50,000, that actually is a pretty good estimate. Last one, fourth one, I went down to 100, so I came up to 1,000,000. Gave me an estimate again around 10,000. The actual math, 8,504. So we were good, really close. And the last one you guys are supposed to have done together in class. My estimate, the 245 was a tough one, so I decided to go ahead and go down to 200. Because I went down, I went up to 2,000,000, gave me an answer around 10,000. So my actual answer, 7,443. Again, not a bad estimate. Questions on any of them?
No.
How are you guys feeling on building these tables? Okay, the good news is we're going to give you more practice. Please be quiet. This is the important part. We need to listen to the instructions. Okay, on your homework. I personally felt that since I have to work Monday and you don't, and this won't actually be due till Wednesday, that we should give you guys plenty of work. We had 20 problems to choose from. Miss McShann said that's probably a little much because we do need you to do the multiplication table for every one of them. So you only have to do the first 10. Guys, listen. Listen. If you do this and do your multiplication tables, this one page is not going to be enough. Do a separate piece of paper. You must have a multiplication table for every one of these problems. Now, a couple of them have already been built for you. We just did 78. We've done 19. So you may copy them, but you need to have them on your papers.